Here we're asked to find the limit as x approaches negative infinity of this rational expression. Notice we have an x squared inside a square root, and we have a linear expression here on the bottom. Okay, this one's a little tricky, so I want to go over a little bit of algebra before we jump into it. First thing we need to know is that the square root of x squared is equal to, you would think that's equal to x. But in fact, x could be negative. It's actually equal to the absolute value of x. And so the absolute value of x we know is x if x is greater than 0. And it's the opposite if x is negative, right? That's if x is less than 0. Okay, so we're going to need this because the technique here is to multiply numerator and denominator by the same thing, 1 over the absolute value of x. Okay, so multiplying top and bottom by the same thing, you're not really changing the problem. But what we're going to do is choose wisely, knowing here that x is tending to negative infinity. X tending to negative infinity sort of guarantees that in the end, our x values are actually going to be negative. Okay? And that's important here because for the numerator, certainly for the numerator, we're going to choose the version of absolute value of x. We're going to choose square root of x squared. Okay? And for the denominator, now we chose the square root of x squared because that's going to pass into this radical. The x squared can go in. But for the denominator here, we're going to choose the version of absolute value of x. We're going to choose the opposite of x, or negative x. Okay, so we're going to multiply the bottom here by 1 over negative x. And those are equivalent. Square root of x squared is equivalent to negative x under the condition that x is tending towards negative infinity. Okay, that's kind of tricky there, but watch what it gives us. X tends to negative infinity. Here, the square root can pass inside there, and so we'll actually have 3x squared minus 2 over x squared, where of course all that's underneath the radical. And then on the bottom here, when I distribute this, well, instead of distributing it, I'm just going to write it as x plus 5 over negative x. And I'll take that distributed step as the next step. Okay, so that leaves me with the limit as x approaches negative infinity. Now over here, this simplifies as 3 minus 2 over x squared. And then in the denominator here, we get negative 1 minus 5 over x. Okay, so I'm just dividing both of these terms by negative x. All right. Now at this point, we could see that when x goes to negative infinity, 2 over x squared, right, 2 over something really big, is going to tend towards 0. And then same thing over here, 5 over negative infinity, that's also going to tend towards 0, right? 5 over a very big number. And so when I do sort of the direct substitution, and I analyze this in the limit, at this point I'll be left with square root of 3 over negative 1. Because those two terms are going to go to 0. And that leaves me with the limit here, negative root 3. Now let's go verify our results on Wolfram Alpha. Alright, so here we are at wolframalpha.com, and I'm going to go ahead and type that in. So the limit as x approaches negative infinity, so I'm just going to type in negative INF. INF is short for infinity. Now the numerator was square root 3x squared minus 2, and then we were dividing that by the quantity here, x plus 5. Alright, so I'll go ahead and hit the equal sign and see what we get. Alright. So it looks like I typed it in, x approaches negative infinity, and the result is negative root 3. Alright, so we verified the answer. Very good.